All right. So what I wanted to do was I want to talk about organic chemistry. And I want to continue on with the notes. So this one says structural isomers. Now, we've talked about isomers before, but structural isomers is compounds which have the same formula, but a different arrangement of atoms. So in this case, C4H10 can either be drawn in a line, 1, 2, 3, 4, or you could be drawn as 1, 2, 3, and there's another carbon off to the side. But if you take a look at the two formulas, they are actually exactly the same. C4H10. 4 carbons, 3 plus 2 plus 2 plus 3 hydrogens, 10. 4 carbons, 3 plus 3 plus 3 plus 1 would be 10. An example of this would be like, I used this before, gain versus China. The same 4 letters, but because they're arranged differently, this is what you would consider structural isomers. Okay. Now, remember I said last day's lesson on Friday was really, 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 really important. Because everything that we're going to talk about today is going to be based upon what you learned last day. Some of the same patterns you will see. Now, when we talk about alkanes, one thing is this. If we move it up here, methane, ethane, propane, and butane are gases at room temperature. Butane is easily liquefied under pressure. Pentane and longer chains are liquids. This is why propane for your barbecue. If you smoke the butane, what that is usually a gas. Why is it a liquid? It's because it's under high pressure. Okay? So if you were to release propane, if any of you went camping this past weekend, the propane in those like green Coleman stove things, those are gas under high pressure. And they stay gases, but sometimes they can be liquefied. Gasoline, it is considered a liquid because it's a longer carbon chain. Candles like beeswax and all that stuff is alkanes, but they're a very long chain. That's why they're a solid. So if you've ever burned a candle, whether it's a beeswax candle or just a regular candle, it is considered an alkane, but they are solid because the chain is so long. The carbon chain is so long. Okay? Now, what I gave you last day was the basic foundations for everything else. Now, there's something called cycloalkanes. Cyclo means that they are connected in a head-to-tail circle, are called cyclic hydrocarbons or cycloalkanes. Now, they give you an example of some common cycloalkanes. Here is cyclopropane, upper left. Why? The propane means 3 carbons. The cyclo means that they are forming a circle. The A and E means that it's all single bond. This is cyclobutane. Cyclo because it's a circle. Bute because there's 4. And ane means that they are all single bonds. Okay? Now, we have cyclopentane on the upper right. Cyclo because it's a circle. Pent is 5. Ane means single bond. Now, if any of you are planning to take biology 12, you are going to be learning about sugars, fructose, lactose, glucose. All those, their main chains are the cyclohexane or cyclopentane and how they are joined together. Okay, so if I said, oh, it's a cyclohexane ring, you should know that it means 6 carbons, all single bonds in a circle. That's what a cyclohexane is. Okay? Now, there are some rules. And the one thing nice is that when you go through this, is actually very, very straightforward. Substituted cycloalkanes follow the same rules as a straight chain alkane, except that a single substituent does not use a number. And if there's more than one substituent, the first substituent is assumed to be at the 1 position, and the remaining substituents are numbered either clockwise or anti-clockwise to have the lowest set of values. Now, put it away, Danya. What are you watching? Okay. Now, again, in this case, you have methyl here. You have methyl here. Okay. Now, the cyclohexane is this here. This would be the cyclohexane. Okay? It's the same type of pattern. Now, notice, because there's one group, I did not need to put a number. Okay? If there's only one attached to it, you don't need a number. Now, how about this one here? 1-ethyl, 2-methyl cyclohexane. So in this case, you have the ethyl group here. You have the methyl group here. And then you had the cyclohexane, which is this group right here. Now, if you take a look, what happened is they started the numbering right here. They went 1, 2, 3, 4, 5, 6. Now, the question I have is, why did they not go in this direction? Why didn't they put this as 1 and go to 2, 3, 4, 5, 6? Why didn't they start at the very right carbon and go 1, 2, 3, 4, 5, 6? Why did they choose the bottom right carbon And so 1, 2, 3, 4, 5, 6. Both give you the smaller numbers. But why did they choose that? Why didn't they put 2 ethyl, 1 methyl cyclohexane? Why did they have 1 ethyl, 2 methyl cyclohexane? But why didn't they do it this way? Oh, sorry. 2 ethyl, 1 methyl. One. Come on, people. But why? Why did they put the 1 ethyl 2 methyl? Yes. What? You still have using numbers 1 and 2, 1 and 2. What's the difference? Why did they prefer this one? Why didn't they? Both are right. But why did they prefer this one? What about it? Yeah, but this is also in alphabetical order. So they're both alphabetical. What do you notice about the sequence and the alphabetical order? 1, then 2, E, then M. Notice it is both sequential. 1 to 2 instead of 2 to 1. Okay? So in this particular case, it's more refined. It's actually a little better. It's not saying that this is wrong, but what happens is this is just more refined. It's like when you are going out on a date, guys, make sure you shave, make sure you vacuum your car. You don't have to, all right, but it'd be nice. So in this case, given a choice, this one is preferred because not only does it follow alphabetical order, but it also has chronological order. Okay, so something for you to be aware of. Now, this one down here, notice 1,1-dimethyl. Why? Is because this carbon is number 1. This will be number 2, 3, 4, 5. And since there is more than one grouping on there, each one has to have a number. Okay? Please note the difference between up here with no number, down here with a number. Okay? Why did this one have to have a number? Is because they have more than one grouping attached to the main branch. Okay? So again, all of these follow the rules that you had learned from day 1. All right? All right. Now, move over to the next one. It says alkyl halides. Now, in this case, it says the alkyl halides What are they? They are the halogens. Fluorine, chlorine, bromine, iodine. Okay? Now, attached fluorine, chlorine, bromine, and iodine are called fluoro, chloro, bromo, and iodo groups. Use a number to indicate the position of the attachment on the hydrocarbon chain. Notice, if more than one of the same kind of halogen is present, use prefixes. Di, tri, this is the same stuff we've done. Okay? And if a compound contains both alkyl and halo groups, list the attached groups in alphabetical order. Hey, everything's in alphabetical order. Starting numbering from the end, which gives the lowest set of numbers. Notice it's the same pattern. Alphabetical order, lowest group of numbers, the same thing. So when you take a look at the examples, notice, why is this 2-fluoropropane? Again, propane because of here. That would be propane. And then 2-fluoro is right here. 2 because the fluorine is found on carbon 2. Now, unlike the situation involving the addition of alkyl groups, halo groups can be placed at the 1 position. For example, CCl3, CF3, it's 1,1,1 trichloro 2,2,2 trifluoroethane. Now, how does that look? It would look something like this. C, F, F, F. Okay, so here the ethane is right here. 1,1,1 trichloro right here. And then 2,2,2 trifluoro is right here. Now, in this case, you will notice that there's no hydrogen present. All right, because of the fact that carbon, there is a grouping of 4. Okay. So what you have is you have carbon here already with 4. 1, 2, 3, 4. So I don't need to put in any extra hydrogen. Okay. Now, one thing about alkyl halides, this one right here. Compounds with many fluorine atoms tend to be unreactive or inert. Teflon is a highly fluorinated hydrocarbon, which is inert to almost all chemical attacks. This is why Teflon is considered non-stick. The reason why it is non-stick is because it is not reacting with anything. But there is a problem with Teflon. So what is the issue with Teflon? What's the issue with Teflon? Good. Not correct. So check it right now. I think it's pulled off. Okay? So what's the issue with Teflon? What's the issue with Teflon that you folks are aware of? How many of you have Teflon pans at home? How many of you have non-stick pans at home? None of you? Sorry? You have Teflon pans? Yeah. You guys have non-stick baking ware? Yeah, that's Teflon. Here's the problem with Teflon. It can get scratched off. So this is why you folks always have to use plastic or rubber, okay? But eventually Teflon will scratch off and can get into your food, all right? So you can get something carcinogenic into your food. The second thing is if you heat Teflon too much, what happens is that it can release fumes that potentially can be dangerous to you, okay? So this is where Teflon is great if you're frying an egg and you want non-stick. But if you want to sear something, like if you have a steak or you want something with really high heat, you cannot use Teflon. This is why if you go into any restaurant, whether it's White Spot or McDonald's or any higher end Cactus Club, they do not have Teflon anywhere in their kitchen because they cannot get high enough heat. Okay, and so this is why a lot of people now are actually moving away from Teflon. What they're doing is they're cooking with stainless steel or they're cooking with cast iron. And if you prepare cast iron well enough, if you oil it and do not wash it, like when you're done with your cast iron and you just wipe it and you put oil, it is just as effective as a non-stick pan. Is that right, Hassan? Yeah, right? So this is why if you ever watch professional bakers or professional cooks, it's very rare that they use non-stick pans. Okay? But that's what Teflon is basically an organic compound made of carbon with tons of fluorine all around it. And that's what makes it non-stick. Okay? All right. The last one that I'm going to stop here and then give you folks time to work is double and triple bonds. Okay? That's in the big sheet, the stapled sheet that I gave you. Okay? Now, if a double bond is present, you change the A and E ending to E and E. If a triple bond is present, then change the A and E ending to I and E, Y and E. Use a number to indicate the lower numbered carbon atom involved in the bond. The bond goes from the lower number to the higher numbered one, and the number goes immediately in front of the name of the parent hydrocarbon. Number the parent hydrocarbon to give the double triple bond the lowest possible number. If the number is the same starting from either end, start the numbering from the end closest to the first branch point. So, out of this whole thing, what do we recognize? If you have a double bond, you change it to E and E. If you have a triple bond, it is Y and E. If you have a single bond, it's an A and E. That's what we have down here. And basically, when you number, start with the double bond gets first priority in terms of the numbering. All right. So what do I mean by this? Okay. So in this case, they said write the formula for 2-hexene. Now, if you read the little bullets, it says hex means 6. So I drew 1, 2, 3, 4, 5, 6. The E and E ending means that a carbon double bond is present, and the 2 means that the bond starts at carbon 2 and goes to carbon 3. So how would that work? So here, this would be 1, 2, 3, 4, 5, 6. So the 2 means that it's between carbon 2 and carbon 3. If I said 3 hexene, it would be between carbon 3 and carbon 4. If I said 1 hexene, it's between carbon 1 and carbon 2. Okay? Now, here, why is it 1 pentyne? Pent means 5 carbons. 1, 2, 3, 4, 5. I means a triple bond. And the 1 means between carbon 1 and carbon 2. Okay? Now, in this case, if you take a look, they give you some examples of how the formula looks. Let's say for this one down here, 4-methyl 1 pentyne. Why is it 4-methyl? Is because they started here. 1, 2, 3, 4, 5. They started from the left here because you want to give the triple or the double bond the first priority. So that's why it's 1, 2, 3, 4, 5. It's not the other direction. It's not 1, 2, 3, 4, 5. Okay? So the double bond always gets first priority compared to everything else. Okay? All right, one final thing, and then I'll give you time to work till about 2 o'clock. Then we take a break, and then we will talk about a little bit more of the double bonds. Now, this last one. Now, how did we get the 3,3-dimethyl 1-cyclopentene? It goes like this. 1, 2, 3, 4, 5. Now, you might say, Mr. Chan, why don't they do this? Why doesn't it go 1, 2, 3, 4, 5? Why isn't it 2,2-dimethyl 1 ... Why is this wrong? Why did I have to start the numbering down here? Why did I have to start on the bottom right-hand corner? Why couldn't I go to the upper right-hand corner and start with the 1 there that's written in orange? Correct. The double bond has to be between sequential numbers. 1, 2, 2, 3, 3, 4, 4, 5. Here, the double bond is between 1 and 5, not sequential numbers. Okay? So a little tip. All right.